You are now tuned in to the network, the YouTube channel that takes complex networking topics and dumbs them down in more simple language. Today's topic is configure and verify tracking objects, subsection 6.10a, tracking objects. This is a topic in the CCNP route exam. It'll be known as CCNP Enterprise. Come February 24th, 2020. Let's go ahead and take a look at the exam blueprint and see where we came from and where we are headed. Hashtag LabEveryday. Also, visit labeveryday.com. Please hit the like button before you leave and also subscribe to my channel. It's the exam blueprint implementing Cisco IP routing, exam code 300-101. It'll be known as 300-401 once this exam retires. We did configuring and verifying IP SLA. Today we're going to do something similar, but we're going to configure and verify tracking objects. And then we're going to be tracking different entities as well. I believe we'll do that in a separate video. Yeah, so what are tracking objects? Basically, it's similar to CCNP. You know how we have these, we take parts of a router or a switch or whatever, and then as soon as something happens to it, like say an interface goes down, we'll get what's called an CCNP trap, a message that tells us, hey, this interface went down, or hey, this interface just turned up, or hey, somebody made a configuration on this router, something like that. We'll get a trap, right? Well, we can configure what's called tracking objects, and a tracking object is basically, again, like parts of a router or a switch. We could also track, say, a route somewhere. Let's say a route goes down, boom, we'll get a notification. Usually because, you know, like with static routes, for example, which we're going to do in the GNS3 lab, if a static route goes down, or if a static route, or for an interface that a static route points to is down, we're not going to know about it, right? We're just going to have a static route that still points to that way and wonder why we can't reach it, right? Well, we'd have to ping it and find out, oh, okay, it's down. Well, tracking objects will sort of give us like an automatic alert to let us know, hey, this interface went down. That's why your static route is not working. Let's head over to the slides for the official definition. Object tracking. Object tracking allows you to track specific objects on the device, such as interface line, line protocol state, IP routing, and route reachability, and to take action when a track object's state changes. So if you look at this example right here, actually the GNS3 lab we're going to do something very similar to this. We have the local area network here on the left-hand side, right? To get out to the internet, they go to router 1, right? That's their default gateway. But we have a primary link as well as a backup link, right? So this could be like a dual-homed, you know, ISP connection that we have to get out to the internet, right? Well, let's say we have a static route that points this way, right? Obviously, we could do, you know, a routing protocol like HSRP or something like that, or you know, like a standby routing protocol like VRRP to basically, you know, point to the other router if one goes down, right? Well, you could also do object tracking, which will give you an alert to let you know, hey, this went down, and then also take action. And that's what object tracking does. So like, let's say we had a static route pointing to router 2 as our default gateway or as our default route to the internet. Let's say this one goes down, this interface goes down. If we're tracking this object, right? This as an object, this interface will be as an object, right? If that one goes down, we will receive a notification, right? Well, not necessarily, no. You'd have to be configure debugging to really see the notification, but it'll automatically fail over to the secondary link, and then we'll start, you know, using this to get out to the internet. Now, again, you could set up HSRP or VRRP, so any kind of redundancy protocol to kind of do this, but object tracking, obviously, is interface line protocol states, IP routing, and route reachability. So it is similar to redundancy protocols. Here is a way to configure it. You configure a track object by simply just typing track. You put the object number, you just create, you know, you just make one, right? And then with this, you can we can track an IP SLA operation here and its reachability. So like, you know, in the last video, we set an IP SLA to just ping a specific web server, right? Let's say we ping it, we're pinging it every like 5 seconds, right? As soon as that web server goes down, we're not getting a response from that web server. If we're tracking that as an object, boom, it's going to let us know, hey, this object went down, and then we'd have to set action. You know, we'd have to set action, and we could do that with reachability or just track the state. In this case, we could do reachability. If we could say, if we're not able to reach this, here, take this action, you know, either take another route or cease traffic altogether, which it'll do automatically. There's so many things you can do. You could also here If you would like to configure a delay on the object to regulate the flapping of the object, like if something's going up or down, up and down, you can say the delay, if we're having some flapping that's down for like something that's down for more than a minute, then yes, take action if we're tracking this object. We could do a show track to verify our track objects. With this lab, we're going to do, I believe we're going to track an IP SLA monitor. Let's go ahead and fire up GNS3. Y'all know what it is when y'all see this little girl. You can also get a copy of this lab at gns3volt.com. That's the link right there. I will leave a link in the description below. I will also leave it in the comments because I noticed some people don't click the show more to see what's in the description. But anyways, let's go ahead and play with object tracking. All right, so here's the lab we're going to be working with today. We got router branch over here on the left-hand side. We got router headquarters, and we got router the web server over here, right? So branch has two links to take him to headquarters, right? He's got this primary link, which will be the fast Ethernet link right here. And what we're going to do is set up object tracking for that. So that way, when that one goes down, he will fail over to the serial connection, which is over here in the 21.0 network. We'll actually also set up so that way when the web server goes down, he will use the backup link. We're also going to set up IP SLA so that way he's pinging the web server. And when that web server is no longer responding, he'll fail over to the backup route. So step one says here to configure router branch, which is this guy right here, with a static route to reach the web server through the fast Ethernet link, which is right over here. Okay? So let's go ahead and do that. First thing we want to do is set up a static route. So we're going to go to privileged exec mode, then go to global config mode. We're going to say IP route 192.168.23.0, and then the subnet mask is 255.255.255.0, and then next hop will be this guy right here, the fast Ethernet route, which is 192.168.12.2. So take the next hop of 192.168.12.2. I promise y'all I can type faster than this. It's just that I'm using the mouse on top of my laptop here. So anyways, that was step one. Step two says configure router branch, which is this guy again, with another static route to reach the web server, which is this guy down here, through the serial link. Make sure this static route is only used when the fast Ethernet static route disappears, which is that one right there. So when this one disappears, it needs to be using that route right there. So let's go ahead back in the branch and create another static route. That one's going to be IP route. And also, you notice he says that it needs to disappear. So that means we need to create what's called a floating static route. If you don't know what that is, go to my CCNP playlist on my channel, and you'll see I did I think 2 or 3 videos on static routes. We briefly talked about floating static routes. But anyways, it's basically like a backup route. So we're going to say IP route 192.168.23.0, set the mask to 255.255.255.0. Next hop is going to be 192.168. The backup route, which is this guy right here, which is at 192.168.21.0. So 21.2, which is the next hop. So that is the backup route right there. But we wanted to, otherwise it's going to use both of those right there, right? So we need to create a static route, which means we'll have to modify the administrative distance, and we're going to say 10. Let's go ahead and take a look at what his routing table looks like. Show IP routes. And now he's going to be using this route right here, 12.2, which is the fast Ethernet link to get to the headquarters router, right? Let's see if we can ping the web server right now, which is 192.168.23.3. Success rate, that didn't look good. Let's ping it again. Now we got 100%. So we've done that. That was step 1 and step 2. Step 3 says configure IP SLA on router branch to ping the IP address of the web server. Once it starts, it should never stop. All right, so we are going to create an IP SLA on router branch. We want him to ping the web server, and it should never stop, right? So he wants it to consistently ping it like that, right? So we need to make sure we set a frequency. Let's go ahead and go back to router branch. We're going to say, if you remember from the last video, we said to do that, we're going to go to global config mode and say IP SLA monitor, and then we're going to create an entry number for it. So we'll just do monitor 1. We'll be in SLA monitor configuration mode, right? So from here, we said we wanted to ping the IP address of the web server. What options we have here? We can exit out of this mode or type. So obviously it's got to be type, right? What type of SLA do you want to do? DNS, frame relay, FTP? Well, we said echo because there's no ping in here, right? Path echo might sound like it, but it's really just echo is what we want to do. So type echo. What's the next thing? We know it's protocol. Next thing, IP ICMP echo. What's the next thing? They said they want the host name or the IP address that we're trying to ping. So in this case, we're going to ping the web server, which is 192.168.23.3. So let's go ahead and do that. What else they want us to do? Source interface or source IP address? They didn't specify. So we're just going to hit enter here. Now notice we are in SLA monitor echo configuration mode. So what are the next things they said they wanted us to do in here? It says once it starts, it should never stop. Let's worry about the schedule later. That's called the schedule. Let's go ahead and give it a timeout period. And we want it to time out. So in other words, if we don't hear from the web server by this amount of time, we want it to take action, right? So in this case, we'll put 5,000 milliseconds, which I believe is pretty much like 5 seconds. How often we want to do this? We want to frequency. We want to ping it maybe every 10 seconds. And what else do we want to do here? So we're going to ping this guy every 10 seconds. I believe that's all we've got set up for the SLA at this moment. So let's go ahead and get out of this. Set up the schedule now. Let's go ahead and set up schedule. IP SLA monitor schedule. What else we got here? We got the entry numbers. Entry number 1. What was the schedule though? We didn't even finish that. So schedule 1 is going to be, he didn't specify what start time. So we'll just say start time at this point. When do we want to start? He didn't say when, so we're going to say now. We're just implying that, right? What was the next thing he wanted? He wanted it to, he said, once it starts, it should never stop. So what a word in here tells you that? Life, right? Life, 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 life. Sorry about my bad singing. Life. Oh, what else we wanted? Life. After that, forever.
Forever, 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 ever, forever, ever.
All right, so that is the schedule. Let's see what we got so far as IP SLA is concerned. So IP SLA monitor, we're going to do configuration. Take a look at that, and we've got, as you can see here, entry number 1, we're going to be pinging 23.3 every 10 seconds. We didn't set any of this up. We did the timeout at 5,000 milliseconds. Start time is already passed, right? Because we said now, then, right? Life, so this will be running forever. We've got in here, all of this is default stuff. We didn't touch any of that. Let's go ahead and also check the statistics for that. Show IP SLA monitor statistics. Which one? 1. What else we got in here? We've got 5 successes, 0 failures. So at this point, we are pinging this guy every 10 seconds, right? We should set him up as a responder. Let's also set a default route out to this way. This is something else that Renee Molnar didn't, really, sometimes he creates these labs, but he don't give you every single step that you got to do unless you watch the video solution, right? And also another thing is if you download this lab from his site, you'll notice these numbers are transposed here. So be careful. I was just looking at this and thinking, oh, because this said 12.0. Anyways, just make sure you pay attention to the interfaces and their addresses. So we're going to go into web server, create a default route out to the headquarters router, enable global config mode, right? We're going to say IP quad 0. Subnet mask is also quad 0. Take the next hop of 23.2. 192.168.23.2, right? So we're basically saying, oh, I forgot the route keyword there. Routes. All right. So we're basically saying, you don't know what to do your traffic, send it out this way to 23.2, right? That's basically what we're saying. Let's also make him a responder. We're going to log into this bad boy, and we're going to say IP SLA monitor responder. All right. And let's go ahead and check the statistics here. We got 16 successes, no failure. Let's go ahead and see if we can ping the web server again, 23.3, right? So we were able to ping him, right? We're sending SLA, right? Next thing here says, okay, so we did step 3. Step 4, it says if you don't receive a ping for 5 seconds from the web server router, branch should remove the static route for the fast Ethernet link from the routing table. If everything goes okay, all traffic would now be sent through the serial link. All right, so let's go back to branch. We know we got to do that on branch. On branch, let's say, first of all, we need to do, this is the object tracking part. So what we're going to do is we're going to go to global config mode. We said to configure a track object, you just type in the keyword track, and then you put in the object number. And from there, you're going to add IP SLA and then check its state or reachability of what you're trying to track. In this case, we are going to track the fast Ethernet interface. That's the primary link. This primary link, we want to track this. If it goes down, please go ahead and fail over to that address, right? I mean, that interface right there, right? So let's go ahead and do that. So we're going to say track. We're going to put track object number 1. That's another thing too. We got to tie this track to the static route. And I'll show y'all how to do that, which means we got to remove that static route that we created. That's another thing. Renee don't give you this stuff in order. So that's why I got kind of tripped up with this lab here, but Renee likes to challenge us here. We could track a specific interface to track, an IP protocol, a list, or response time route reporter. We're going to do response time reporter, which is basically SLA. So we're going to do RTR. That's the keyword for that. Entry number 1. We want to test the reachability of basically that static route right there. So the static route of this, we want to track the reachability of that interface right there. So let's go ahead and, we're going to enter that right there. We could do show track. And notice reachability is up, right? What else we want to do here? Let's go ahead and debug track. That's going to let us know when things are up or down, our objects, when we do object tracking. Let's go ahead and see what happens when we go to the headquarters router and shut down the fast Ethernet interface. Right now, remember, to get to the web server, he takes a fast Ethernet interface. But what's going to happen when the web server or the headquarters router interface goes down, that next hop right there? Let's go ahead and shut down this next hop on the headquarters router. So fast Ethernet 00. Before we do that, let's verify that routing table again. Show IP routes. Remember, that's what we need to do. We need to remove that static route, that other static route. Let's do show run include routes, right? What's the, that's also what we got to do. We got to set the tracking to this. We're not tracking this route right here. So let's go ahead and remove that. Go to global config mode. I'm glad we tested it first. Global config mode. We're going to say no IP this. Put it back and say, right, because we're tracking that fast Ethernet interface. So IP routes 192.168.23. Matter of fact, when you watch Renee's video solution, he kind of forgets this too. So I kind of remind me of that. So 23.0 network, subnet mask 255.255.255.0. Take the next hop of 192.168.12.2. But we're going to, if you do context sensitive help, you see other options here. We can change the administrative distance like we did with this first route over here. We can specify a name of the next hop. We can do a permanent route, so that way it'll stay there no matter what the deal is. We can set a tag for this route, or we can do install a route depending on tracked item. In this case, that's what we're going to do. We're going to set this static route as a tracked item. So we do track. Which track number? It was track object number 1, right? So we do that. Notice now we're going to start tracking for the static IP routing. Let's go ahead and take a look at that routing table again. Show IP routes. And so now we still have that fast Ethernet link as our primary link and our way to get to the web server, right? Now let's shut down the web server. Let's go to interface FA00. We're going to shut that interface down. Go back to branch, see if he still has a route to the 23.0 network. He does. And it's a static route pointing that way. We are okay. We got reachability going down. So now we've shut down the web server. Now let's take a look at our routing table. He was using the Fast Ethernet 00 link, show IP route. And now you notice he is using the serial link, just like we planned. So yeah, so basically he still has a route to get to the web server, even though we can't contact it. So, and notice the AD is changed. It is 10. Remember that first static route, which was the Fast Ethernet interface, was 1. So if we bring it back up, the web server, shut, go back to branch, give it a couple seconds here. Reachability went down and up. Let's check our routing table again. Show IP route. How do you get to the 23.0 network? Back to the Fast Ethernet link. That is all I got for y'all today. I kind of struggle with this lab. I'm going to keep it 100 with y'all. That is about tracked objects there. I may need to do some practicing, and I hope you guys do some practicing as well. Try to look for some other labs. I have some other labs that I amassed throughout the years with my networking studies. But anyways, that is my YouTube page. That is my Twitter handle. Hit me up on social media. Please leave a comment below on what I could do to improve these videos, other than find a more sound area where I'm containing my sound and getting a better mic and lighting. But anyways, please comment, like, subscribe to the network.